Welcome to Asim Code. Hey there. It's great to see you. Make sure to like and subscribe to join the community. Java socket programming is a way for applications to communicate over a network. It involves using the socket and server socket classes in Java for network communication. There are two primary protocols for socket communication: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Both are used for sending and receiving data across networks, but they differ in how they handle the communication. TCP, Transmission Control Protocol. Key characteristics of TCP: connection-oriented. TCP is a connection-based protocol. This means before data is exchanged, a connection must be established between the client and server. This process is known as the three-way handshake. Handshake. The client sends a request to connect, the server accepts it, and the client acknowledges the connection. Reliable. TCP ensures that data is delivered reliably, in the same order it was sent. If any packet is lost, TCP will automatically retransmit the missing data. This is why it's considered a reliable protocol. Flow control and congestion control. TCP uses mechanisms to control the flow of data to prevent network congestion and ensure the sender does not overwhelm the receiver. Heavy overhead. Because of the connection setup, error handling, and data sequencing, TCP requires more resources and introduces some latency. Advantages of TCP: reliable communication. Data is guaranteed to arrive correctly and in the same order. Error detection and correction. Lost or corrupted packets are retransmitted. Flow control. TCP adjusts the data flow to prevent congestion. Disadvantages of TCP: slower. The overhead for establishing connections, maintaining reliability, and handling errors introduces latency. Complexity. The protocol is more complex than UDP due to its error handling and flow control mechanisms. UDP, User Datagram Protocol. Key characteristics of UDP: connectionless. UDP is a connectionless protocol, meaning there is no need to establish a connection before sending data. Data can be sent directly from the sender to the receiver without any handshake or connection setup. Unreliable. UDP does not guarantee the delivery of packets. There is no acknowledgement of receipt, and packets may be lost, duplicated, or arrive out of order. Faster and lower overhead. UDP has less overhead compared to TCP. Since there is no connection setup or error handling, EUD is faster for sending data. This makes it suitable for real-time applications like streaming or gaming. No flow control. UDP does not have any flow control or congestion control mechanisms, which means it can overwhelm the network if too much data is sent in a short period. Advantages of UDP: faster, no connection setup, error recovery, or acknowledgement leads to faster data transmission. Lower overhead. UDP has minimal packet headers and no need for error handling, making it lightweight. Disadvantages of UDP: unreliable. There is no guarantee that the data will be delivered or in the correct order. No error correction. Lost or corrupted packets are not automatically retransmitted. This Java code example demonstrates how to implement both TCP and UDP communication protocols in a simple client-server application. It allows the client and server to exchange messages, showing how each protocol behaves and handles communication. Importing Java's networking package for socket programming. Importing Java's I/O package for input-output operations. TCP server method. This method runs the server-side logic for TCP communication. Create a server socket object that listens for incoming client connections on port 1234. Server socket waits for a client to initiate a connection. The server accepts an incoming connection request from the client. This returns a socket object that is used for further communication with the client. Buffered reader reads the input stream from the client. It helps to read the client's message sent over the network. Reading a line of text sent by the client and storing it in the message variable. PrintWriter is used to send a response back to the client. It sends the string, "Hello, client! This is the server," to the client. After the communication, we close both the client socket and the server socket. Closing both sockets releases resources. TCP client method. This method runs the client-side logic for TCP communication. Create a socket object and connect to the TCP server on localhost at port 1234. This is where the client initiates communication with the server. Print writer is used to send data to the server. It sends the message, "Hello, server. This is the client," to the server. Buffered reader reads the server's response from the input stream. The server sends a response back, which is read and stored in the response variable. Display the server's response. After communication, close the socket. Closing the socket releases the resources. Handling any I/O errors. UDP server method. This method runs the server-side logic for UDP communication. Create a datagram socket object to receive UDP packets on port 1234. Datagram socket is used for connectionless communication. Create a byte array buffer to hold the incoming data. Buffer size is 1024 bytes, which is a common size for network packets. Receive the incoming UDP packet. This method blocks until a packet is received. Extract the message from the packet. Display the received message. Prepare the server's response message and convert it into bytes. Convert the response string to a byte array. Create a datagram packet with the response data and send it to the client. The packet includes the address and port of the client. Send the packet to the client. Close the datagram socket after communication is finished. Handling any I/O errors. UDP client method. This method runs the client-side logic for UDP communication. Create a datagram socket object to send UDP packets. Prepare the message that will be sent to the UDP server. Convert the message into a byte array. Get the server's address, localhost, and port 1234. Create a datagram packet containing the message data, target server address, and port. Send the packet to the server. Create a buffer to receive the server's response. Buffer size of 1024 bytes to receive the response. Receive the response from the server. This blocks until the server responds. Extract the response message. Display the server's response. Close the UDP socket after communication is finished. Handling any I/O errors. Start both TCP and UDP server and client communication in the same program for testing. Run TCP server in a separate thread. This allows the TCP server to listen for connections. Start the TCP server thread. Run UDP server in a separate thread. This allows the UDP server to listen for packets. Start the UDP server thread. Allow some time for the server threads to start before the clients send requests. Sleep for 1 second to give time for servers to initialize. Run the TCP client method to initiate communication with the TCP server. Run the UDP client method to initiate communication with the UDP server. Handling any interruptions in the main thread. Now run our code. That's all for today. Please like, comment, and subscribe to see more.